Welcome back to Mr. Vaughn's classroom, where math is made easy. Before we get started on the video, I'd like to ask you to please subscribe to the channel, give this video a thumbs up, and engage with a comment below. If you find this video helpful, in the pinned comment you'll be able to find links to where you can book one-on-one tutoring sessions with me. In today's video, we're looking at geometry. This is Unit 3, Lesson 16 in the illustrative math curriculum. This lesson is titled Finding All the Unknown Values in Triangles. We have one learning goal in this lesson, and that says I can solve problems involving similar right triangles. For our lesson summary, we have multiple strategies to find unknown side lengths in similar right triangles. Here we know that angle A is similar to angle F. Because triangle ABC is a right triangle, then we can write the Pythagorean theorem 4 squared plus x squared equals 5 squared. Because triangle FGH is a right triangle, then again we can write the Pythagorean theorem y squared plus 12 over 5 squared equals 4 squared. Because triangle ABC is similar to triangle FGH, there are many equations to write using proportional relationships. We can use any combination of these equations to solve for x and y. By similarity, 5 over 4 times y equals 4. What they did here was they took the 5 that's the hypotenuse on the large triangle over the 4, which is the longer of the two short legs, and they set that equal to the corresponding similar sides in the small triangle, 4 over y. Then they multiplied both sides by y, so they just rearranged the proportion once they wrote it. Once we know that, then we can multiply both sides by the inverse, and we get that y equals 16 over 5. So we've already solved half the problem by finding y. We can then substitute that into the Pythagorean theorem, and we find out that 16 over 5 squared plus 12 over 5 squared equals 4 squared, which is true. Now we need to find x, so by the Pythagorean theorem, if we just rewrite it, then x squared equals 5 squared minus 4 squared, and we know that that's going to equal 9, and therefore taking the square root would give us x equals 3. By similarity, we know that x equals 12 over 5 times 5 over 4, which also equals 3. So we can use any mixture of writing or rewriting the Pythagorean theorem. We can write and then rewrite forms of the proportionality equations that we set up. And in doing so, we can find these missing side lengths. And that's what we're going to be looking at in today's lesson. So now that we're done with the introduction, let's go ahead and take a look at the practice problems. Practice problem 1. In the right triangles shown, the measure of angle ABC is the same as the measure of angle EBD. And we can see that by these markings here. They want to know what is the length of side BE. So let's just label this as x. Now, we know that they both have 90-degree angles, And we know that these two angles for B, ABC, and EBD, we know these are the same. Well, triangles all must add up to 180 degrees on the interior angles. So if these two angles are the same in both of them, then that means these angles here must also be the same, because that's the only way they're both going to add up to 180 degrees each. So we know that because all their angles are the same, these triangles are similar. So now let's match up which sides are corresponding. So we have this side down here at the bottom with a length of 3 is going to be corresponding to the other bottom side length of 2. And we know that the hypotenuse of 5 is going to correspond with the hypotenuse of x. So now what we can do is we can set up a proportion. We can say that the relationship of the bottom side of the large triangle, which is 3, is proportional to the hypotenuse of the larger triangle, 5, in the same way that the proportion of the bottom side of the smaller triangle, 2, relates to the hypotenuse of x. So now we've set up our proportionality. Once we do this, we're going to cross multiply. 3 times x is 3x, and 2 times 5 is 10. Now I need to get x by itself, so I need to get rid of the 3. The opposite of multiplying by 3 is dividing by 3, and whatever I do to one side of the equation, I must do to the other side of the equation. Anything divided by itself is just 1, so we get that x equals 10 over 3. And x is side BE. And so this is how we can use the information that we are given to find the information that we're not given. I hope this explanation makes sense to you, but if you do still have any questions, please feel free to leave a comment below. Practice problem number 2. In right triangle ABC, so let's go ahead and draw a right triangle. Angle C is a right angle. So let's go ahead and label this angle C, and then these can be A and B. We know that side AB equals 13. And we know that side BC equals 5. They want to know what is the length of AC. So let's mark that with an X. Now, by the Pythagorean theorem, we can see that the hypotenuse is the side across from the 90-degree angle, so 13 is the hypotenuse. So we're going to have x squared plus 5 squared equals 13 squared. Well, 5 times 5 is 25. And 13 times 13 is 169. We need to move the 25 to the other side of the equation. We do that by using the opposite of what is there. The opposite of plus 25 is minus 25. And whatever I do to the left side, I must do to the right side. Plus 25 minus 25 on the left cancels it out. And that leaves us x squared. On the right side, 169 minus 25 gives us 144. So now I need to get rid of this exponent of 2. The opposite of squaring x is taking the square root. Whatever I do to the left side, I must also do to the right side. The square root of a square cancels out, and that just leaves x on the left side. The square root of 144 is plus or minus 12, but since this is a side length, we can't have a side length of negative 12. Therefore, it must be positive 12. And this is side length AC. So again, we used the information that we did know, the two sides that they gave us, and we used the Pythagorean theorem to find the third side that we didn't know. I hope this explanation makes sense to you. If you still have any questions, please feel free to leave a comment below. Practice problem number 3. In this diagram, lines AC and DE are parallel, and line DC is perpendicular to each of them. What is a reasonable estimate for the length of side BE? So they want us to find this side over here that I marked with an X. Now we know that both of these triangles have a 90-degree angle. We also know that because we have line AE transecting line CD, then the opposite interior angles are the same. And we know that because the interior angles of a triangle must add to 180 degrees, then if two of the angles are the same, then the third angle must also be the same. So these two triangles are in fact similar because they have the same three angles. Now, once we know that, let's go ahead and figure out what this missing side is down at the bottom of the larger triangle. We can see that the hypotenuse is across from the 90-degree angle, so that's going to be 5. So we've got this missing side down here that we'll call y squared plus 4 squared equals 5 squared. We know that 4 times 4 is 16, and 5 times 5 is 25. I need to move this 16 to the other side, and I do that by doing the opposite of what's there to both sides. And the opposite of plus 16 is minus 16. This eliminates it on the left and gives us y squared equals 25 minus 16 is 9. The opposite of squaring something is taking the square root. The square root of y squared is y, And the square root of 9 is plus or minus 3. And since it's a side length, we know that it can't be minus 3, so it's got to be positive 3. So now we know that our side y is actually 3. So now I've got all 3 sides of the large triangle, but I don't have any of the sides of the small one. What we can do is let's just assume that this smallest side is 1. So if this small side is 1, then we can set up a proportion. I've got the shorter length and I've got the hypotenuse on both of them. So on the large triangle, the short side is 3 and the hypotenuse is 5. We're going to set that equal to the short side on the small triangle, which is 1, over the hypotenuse, which is x. Once we set up this proportionality, we're going to cross multiply. 3 times x is 3x. 1 times 5 is 5. Now I need to move this 3 to the other side. I use the opposite of what's there. So the opposite of multiplying by 3 is dividing by 3, and I do it to both sides. Anything divided by itself is just 1. So we get that x equals 5/3. So the most reasonable estimate for side length BE is 5/3. And we can see that that is answer C. I hope this explanation makes sense to you, but if you do have any questions, please feel free to leave a comment below. So just to review, we did have one learning target in this lesson, and that was that you would be able to solve problems involving similar right triangles. So I hope now you see that through a mixture of using either the Pythagorean theorem and maybe rearranging it, or using proportionalities based on the corresponding sides, you can use the information that you do know to find any information that you don't know, as long as you understand that you have two similar right triangles. I would just like to say thank you for watching. If you find these videos helpful, please hit the subscribe button. That really helps the channel grow. Give this video a thumbs up. Engage with a comment below. And if you do find my method for explaining math to be helpful and you would like some one-on-one tutoring, you can check the pinned comment to find the links to where you can schedule one-on-one tutoring sessions with me. As always, I look forward to seeing you in the next lesson.